There's your thought for the day. Our section we're going to do is 6-4. We're going to do half of it today, half of it next time. So 6-4 is use right triangle trig to solve geometry problems. Our objective is to do that. So trigonometry. Trigonometry is the study of the measures of triangles. The study of measures of triangles. In every triangle there are 3 ratios. You've got A over B, A over C, or B over C. These ratios form the basis of right triangle trigonometry. We're doing right triangle trigonometry. We define these ratios with respect to, in this case, we're going to define them with respect to angle A. Alright, so the sine of angle A, abbreviated SINA, is going to be, well, first of all, let me label the sides of the triangle. In reference to angle A, this side A is opposite angle A. The side B touches A, so we could say it's adjacent to angle A, and the side across from the hypotenuse, from the right angle, is the hypotenuse. All right. So don't get C is adjacent to A, but because it's a hypotenuse, we don't label it as adjacent to angle A. We label it as a hypotenuse. So, the one across from the 90-degree angles, you always call it the hypotenuse. Then the other one touching A is the one we call adjacent to A. So the sine of A is the ratio of the opposite side to the hypotenuse. In this picture, that would be A over C. The cosine of A is the ratio of the adjacent side over the hypotenuse. So in this case, that's B over A. The tangent of A is equal to the ratio of the opposite side over the adjacent side. So opposite over adjacent is A over B. Questions? So you have to memorize these ratios, the sine, cosine, and tangent. What it is over what? Yes.
What? So what's the question? How do you or what?
There's no question. I was saying. Excuse me. You have to memorize these ratios for the sine, cosine, and tangent. Now I want to point out to you, if we evaluated this according to angle B, if we did the cosine of B, what would the cosine of B be? What ratio would it be in terms of letters on the triangle? Cosine of B. Chris? Wouldn't be B to C. That's Shatis.
A to C?
It'd be A to C because A is adjacent to B. and C is the hypotenuse, so it'd be A over C. I'm pointing that out because you can see the cosine of angle B is the same as the sine of angle A. The sine of angle B would be the same as the cosine of angle A. Now the tangents would be inverted, but there's that relationship. Now to help you remember that what the ratios are, there's a saying, SOHCAHTOA, right? Memorize this. You can write it at the top of your quiz or test, and that helps you remember what ratio goes with which function. SOHCAHTOA, sine is opposite over hypotenuse. S is O over H, opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. And TOA, tangent, is the opposite over the adjacent. Now, they came up with this saying a long time ago. Actually, it came up back with Native Americans, lived freely in North America. And what happened was there was a chief, and he was hunting in the woods, and he stubbed his toe on a log. And so he couldn't hunt anymore, and he limped back to the camp. And when he got back to the camp, he asked the medicine man, "What should I do? My toe really hurts." And the medicine man said, SOHCAHTOA. Okay? Thus, we came up with the saying, SOHCAHTOA. All right. Calculate the following. We're going to calculate the tangent of 45 degrees. Okay, the tangent of 45 degrees. So what is tan as my ratio? Yes?
Opposite over adjacent.
Okay, so we find the side opposite of 45 is A, and the side adjacent to it is also A, right? So it equals A over A, so it equals 1. The tan of 45 is equal to 1. Now you'll never do the tan of the 90-degree angle. You can only do sine, cosine, and tangent on the other two angles, something less than 90 degrees. All right, here we've got the tan of 60 degrees. What would my ratio in terms of the A values be as far as tan of 60 degrees? Okay, go ahead, Zachary.
A radical 3 over A.
Very good. A radical, it's opposite over adjacent, so it's A radical 3, which is the opposite. A is the adjacent, so it's A radical 3. Nope, go back. It's A radical 3 over A. And that equals to radical 3, which is equal to 1.7321. Now, we're going to take these trig values out to 4 decimal places. Okay, we'll take them out to 4 decimal places. Tan of 30 degrees. The tan of 30 degrees is what, Nina?
A over A radical 3.
Right, it's A over A radical 3, opposite over adjacent. So it's going to equal to 1 over radical 3, which is equal to 0.5774. All right, now let's make sure everybody can do the trig values on their calculator. So you should have a sine, cosine, and tangent button on your calculator. If you have a graphing calculator, it's probably in the radians mode. It needs to be in the degrees mode. So check your mode, hit mode, and then you go 4 down, and there's radians and degrees. Make sure degrees is highlighted. Otherwise, you'll get answers that are way off.
Wait, radians? Wait, make sure radians or degrees?
Make sure Now, anytime, if I reset your calculator, like you're taking a test and I go around and reset your calculator, you've got to go in and change it back to degrees because the default is radians. I'll remind you to do that. But just know if you're, if you reset your calculator, it goes back to radians. So it needs to be on degrees. So with the graphing calculator, you can just hit tan, and you'll see tan on the screen, and type in 37, and then enter, and it'll calculate. On some scientific calculators, you have to enter the number first, 37, then hit tan, and it'll give you the value. Okay, it depends. If you hit tan and it shows tan on the screen, then you put the number afterwards. You put the number second. If it doesn't put tan on the screen, you've got to enter the number and hit tan, and then it calculates. You'll never see tan on the screen. All right, so everybody calculate tan of 37 degrees. And we'll see what answer you get. And then if you didn't get that answer, I'll come look at your calculator, see what you did wrong. So for the tan of 37 degrees, you should have gotten, so tan of 37 degrees is equal to 0.7536. Did everybody get that? You didn't get that?
I got 0.35.
You got 0.7536.
Oh.
Right. Anybody else didn't get that? Okay. Okay, here's an example problem. The horizontal distance of 150 feet from the base of a building, or at that distance, the line of sight to the top of a building makes a 21-degree angle with the level ground. That is, the angle of elevation to the top of the building is 21 degrees. How tall is the building? Assume the building is perpendicular to the ground. All right. So which function am I going to use to calculate x? Shatis?
You could use the tangent function?
Yeah, we're going to use tan because we know the opposite and the adjacent. So we're going to say tan of 21 degrees is equal to x over 150. Opposite, x is opposite, the adjacent is 150. So then we get x equals 150 tan of 21 degrees, which is equal to what? Calculate what you get. What do you get? What'd you get at, Ellie, what'd you get? Don't know? Okay, Shatis.
I got 57.585.
0.585? You might get something different. What'd you get?
57.5796.
That's what I got. 57.5796.
I think I might have copied it wrong.
Okay, you must have.
I got what you said.
Okay. All right, so then let's go ahead and round this to the nearest foot. So that would be approximately 58 feet tall. some more practice with trig functions. We're going to calculate the following, giving both the exact and approximate answer. So if it's exact, we leave it with the radical. The approximate's going to be the decimal. So what would the sine of 60 degrees be in terms of A? Sine of 60 degrees. Nina?
A radical 3 over 2A.
Yes, because it's the opposite over the hypotenuse. So it's A radical 3 over 2A. You simplify that, the A's cancel. You get radical 3 over 2, which is equal to 0.8660. Carmen, what is the cosine of 60 degrees in this problem? Okay, 60 degrees. We do the adjacent over the hypotenuse. What's adjacent to angle 60? No, that's opposite. Adjacent means next to. A. So A goes on top. What's the hypotenuse? 2A. Right. So that we simplify that equals 1/2, which is equal to 0.5000. Questions there? Okay. Calculate the cosine of 45 degrees. What would it be? Cosine of 45 degrees. Yes, Madeline.
A over A radical 2.
Yeah, it is A over A radical 2, which is equal to 1 over radical 2, which is equal to approximately 0.7071. What's the sine of 45 degrees? Let's call on somebody different. Nick, what's the sine of 45 degrees? No, that's tangent. Tangent's opposite over adjacent. Sine is opposite over hypotenuse. Yeah, it's A over A square root of 2. Same result. Equals 1 over radical 2. That's the exact answer. The approximate answer would be 0.7071. Okay, let's go ahead and do sine of 37 and cosine of 37 on your calculator. Make sure you get the right answers for that. What'd you get, Lexi Nash? Sine of 37. 0.6018. What'd you get for the cosine of 37, Alyssa? 0.7986. Anybody not getting those numbers? All right, good. Let's do an example using trig to determine the feasibility of constructing a tunnel through a mountain. Surveyors want to measure the north-south distance. Okay, they can't measure the north-south distance through the mountain, so they have to use other measurements to figure out what it is. They found that the the distance from A to B, you can see in the picture, along the side of the mountain is 4,284 feet. Angle A is 57 degrees. Angle C is a right angle based on a compass measurement. How long will the tunnel be? Which trig function would I use here? And let's set it up. Madeline Andrews, which trig function would I use? Wouldn't be tangent. Tangent's opposite over adjacent. So our x, first of all, our x is this. This is x. Right? And we know this. So let's talk about what we know. What sides do I know, Shatis?
Well, according to like the right triangle naming.
Don't give me the trig function. What is x? What is that?
X is the opposite.
Right, and what's the 4,284?
Hypotenuse.
It's the hypotenuse. Which trig function uses opposite over hypotenuse? Go ahead, Victoria. Yeah, it's sine. So we'd have some. What would the function read, Victoria? Sine what? Sine of 57 is equal to what over what?
4,284.
Okay, the hypotenuse goes on the bottom.
Yeah, x over 4,284.
Right, x or BC. Let's call it BC. BC over 4,284. Then we have to solve for BC. So to get rid of the 4,284 on the bottom, we multiply the other side by that, so we get BC equals 4,284 sine of 57. And then that's approximately what? What do you get for your answer? Let's do it to the nearest foot. Yes, go ahead, Jordan.
3,593.
Yes, 3,593 feet. Questions? Okay, we're going to stop there. We'll stop there and pick up the rest of this section next time. So you've got homework for this section in Canvas. That's all I've got for you today.
Well, in a section off by like A and B